Today, good and bad sampling. A convenient sample is the first thing. We'll talk way more about it here as we get through the worksheet, but we're just going to define everything first. Consists of individuals of the population who are easy to reach. A convenient sample is people who are easy to reach. Easy to reach. We'll talk about it in a second, but it's a really convenient sample. It was easy to ask those people. That's not a good sample if you get a convenient sample. A voluntary response sample consists of people who choose to be in the survey, choose to be in the sample, I should say, by responding to a general invitation. If you chose to be in the sample, you were a voluntary response person. I think you've definitely heard of the word bias before. A bias is the design of a statistical study that shows if it's very likely to underestimate, that's one word, to underestimate, one second, Ben, or to overestimate the value you want to know. Consists of individuals from a population who are selected from a sample using a fair process. Using a fair process. So we'll go through this. This is all just, like, I didn't like the way I was going back and forth before on some of these lessons, so we just kind of filled them all out, and now let's kind of go through it. So in our Federalist Papers activity that we just did, like, we talked about it. Your own judgment is not a reliable method. We had to, like, use, like, randomness to do this. So let's talk about a convenient sample real quick. Again, that is about the individuals of the population. They were easy to reach. So, I have it right here. Cool, cool, cool. Nice. I did save it. Suppose we want to know how much time students at a large high school spent doing homework last week. That's what we want to know. How much time did you do on homework last week? What if we went to the school library to ask the first 30 students we see in the library about how much time they spent on their homework? What do you think about that? Fair or not fair to ask people in the library how much time they spent on their homework? What do you think? So would you agree that not everyone, but people who usually hang out in the library probably do their homework a lot? You know what I mean? You know? So that's why that is a convenient sample. We can kind of just shorten this up if we need to. We don't need to write every single one of these down. We'll write a couple down. It's possible students at the library are there to do homework and do more homework than the average student, however you want to word that. But that's, like I said, today is kind of common sense. There's a lot of writing to do this, or we could just talk it out, you know, when we get to a couple more examples. But it's like, no, that's not fair to go ask people in the library how much time they spend doing homework, because it's more likely that the people in the library are sitting there doing homework, you know. How do you think those people, when they did the results, would, like, affect the average? Let me read this. The sample makes our estimate for the average amount of time spent. Would it be too high or too low? Like, how do you think they would answer based on the general population? Would that result be too high of an estimate of how much time they spent doing homework, or too low of an estimate how much time they're doing homework? If you only ask those 30 kids in the library, too high or too low? It'd be way too high, because they do a lot of homework, you know? So it doesn't take into account the kids that, like, probably don't do a lot of homework. So that would overestimate. That's bias. Let's try another one. A school nurse wants to know if, like, students at his school are overweight on average. After one day, he walks to the gymnasium across the hall from his office. You see how that's convenient, because it's right across the hall from his office. He walked to the gymnasium and selects the first 20 students he sees. He weighs these 20 students and uses the average mean as an estimate for the mean of all students at school. Why is that biased? You know, like, why is that biased? Thoughts? Gym, right? Who's hanging out with the gym? Fit people or not fit people? Usually. Pretty fit people, right? So it doesn't do a good job of getting the whole population. I'm not saying that everyone in there is fit, but, you know, it's like it's more likely that they are fit. So here's what I said. Students in the gym are likely to be doing physical activity. They don't represent the whole student body well. Again, if this is the last one that you want to write down really good, and then we just kind of talk the other ones out, I'm cool with that, you know. But students in the gym are likely to be doing physical activity or are likely in they're fit or things like that. So they don't represent the students at the school very well. What do you think like that survey would do to the average weight of students that they did? Would it be like heavier or lighter? What do you think? Like if they only did the fit students, would the average be heavier or lighter? Probably lighter, you know, so like that would mean that it's less than the mean weight. They didn't get too many overweight students on that situation. Try another one. A bias, we've already defined it, is something that can either underestimate or overestimate the value. It's not just bad luck. You know, some people think bias is just bad luck in one sample. It means that you didn't get a good sample in the first place. So here's some bias situations. A farmer brings a juice company many crates of oranges each week. So this farmer's job is to bring oranges, right? But there's an inspector. They got to inspect the oranges, right, to see if they're good oranges or bad oranges. He looks at 10 oranges on the top of each crate before deciding whether to buy all the oranges. So big crate of oranges, the inspector only looks at the top. Why could that be biased? What could that farmer do if he knew he was only going to look at the top? What's that? Put the good ones on the top, right? All the bad ones on the bottom. You know what I mean? Would you also agree that if there's a bunch of oranges on the bottom, the weight of the oranges could kind of crush those other ones, you know, and it's like in shipping they could get damaged, you know? Would you believe that the good ones are usually on the top anyway because they don't get like damaged kind of stuff? So that's not good. That inspector needs to randomly select oranges out of the box to see how good the oranges are instead of just looking at the oranges on the top in that case. So that's what I said. You don't have to write it down if you don't want to, but it's just like the good oranges are most likely on top. You know, the good oranges are most likely on top. How do you think that would affect the proportion of the damaged oranges? With the damaged oranges, like if they were to look for damaged oranges, and if they only looked at the good ones at top, would the damaged oranges be less or more, greater than or less than in the crate? I think it would be less because you're not finding any damage, right? You know, when you're only looking at the good ones, you're not finding any damage.